Let's now have a look at the Internet's domain name system, the protocol that maps Internet names to addresses, and how the domain name system, or the DNS, can be manipulated. The domain name system, or the DNS, maps names, like uchicago.edu, to an Internet address, or an IP address. The process proceeds as is shown on this picture from left to right, and from steps 1 to 10. The first step is a so-called DNS query, where a machine that wants to look up a particular name, such as noise.cs.uchicago.edu, issues a query to its so-called local name server. That local name server will then issue a sequence of queries to a set of so-called authoritative domain name servers, each of which is responsible for a particular part of the hierarchy. The root name server is responsible for referring the querier, or the resolver, to another name server that knows about edu. The edu name server then issues a referral to a name server that knows about uchicago.edu names, and that name server subsequently issues a referral to a name server that knows about uchicago.cs names. Ultimately, a name server will know the IP address for the entire fully qualified domain name and return that IP address to the client. A local DNS server, sometimes also called a local stub resolver or a default name server or a default resolver, which is usually topologically close to the clients that use it for lookup. A local host might be configured with that local name server or local resolver, and that configuration may live in a file. That default local resolver may be configured manually, or more commonly, it's often configured automatically via a protocol called the Dynamic Host Configuration Protocol, or DHCP. Usually, you won't even know this is happening because that DNS server is assigned at the same time you connect to the network and get an IP address. A client application that wants to know the IP address for a particular internet name will typically make a call, such as get host by name or get adder info, to get the IP address for a particular name. And that particular call in the client application software is the function call that generates the DNS lookup. Server applications may also use the DNS, but it's far more common for clients to issue DNS lookups because the clients are the ones attempting to reach a destination or server on the internet. The DNS can be manipulated. Because the domain name system has historically not been secured or authenticated, DNS manipulation is a common tactic of internet censors. DNS manipulation is a simple process. A resolver simply returns the wrong answer or the wrong IP address for an internet name. Initially, DNS manipulation was used for monetization of DNS errors, instead of returning a no such domain response. A common use of DNS manipulation was to monetize typos, for example. So if you typed Google with 3 O's or without the E, the correct response for a DNS resolver might be to say that there was no such domain if the domain didn't in fact exist. But there was a time when the operators of domain name system resolvers used these typos or mistakes and tried to monetize them through manipulation or redirection. Now, if an internet censor controls the DNS resolver, it can return any answer it wants to the client. And without security, or a secure protocol like DNSSEC, which we'll look at in a minute, there's no way for the client to actually verify the response. And so the resolver could really return anything it wanted to the client. This type of DNS manipulation has been observed in practice. In particular, researchers observed this happening in Iran on Path in May 2013. Another type of manipulation that we've observed in our own research is manipulation of root server responses. So if a local resolver were to issue a query to a root server to try to, say, find a referral to the edu server, an on-path censor could inject a fake referral from a fake DNS root, thereby poisoning the entire part of the name hierarchy for all of .edu, or any so-called top-level domain, such as com, org, net, or any other top-level domain. Countries have used DNS manipulation to implement censorship on a widespread scale. Here's an example of protesters in Turkey who observed DNS manipulation occurring in their country's ISPs and spray painted IP addresses of the Google DNS local recursive resolvers for other people to use, because the assertion was that those local resolvers operated by Google were not performing manipulation of responses, whereas the DNS resolvers of the Turkish ISPs were manipulating and censoring DNS queries and their results. One defense against DNS manipulation is a protocol called DNSSEC, whereby the DNS records or responses are digitally signed. This protects against data spoofing and corruption, and it also provides mechanisms to authenticate servers and requests, as well as to establish the authenticity and integrity of individual responses. There are two public key related resource records, one called the RRSIG, which provides a signature over the RR set, or the set of responses, and that signature is made using the private key of that authoritative name server that's returning the RR set, or the set of responses. There's also a record called a DNS key, or its corresponding DS record, which is really just a hash or a smaller digest of the DNS key record. And this is a public key. That public key is needed for verifying the signature, the RRSIG, over an RR set, which is signed by the parent's private key. So what we'll see in a subsequent example is that an authoritative name server would return the RRSIG, or a signature over that RR set, signed with its own private key that could be checked with a public key that the client already has from the next level up in the hierarchy. But at that level in the hierarchy, in addition to returning the signed RR set, that authoritative name server would also return the DNS key, or the public key, corresponding to the authoritative name server in the referral. There are also records that a name server can use to prove that a resource record or a response or an answer doesn't in fact exist. So a name server can in fact assert that given a particular query, there's no corresponding answer or IP address, and prove that in fact no answer is the correct answer, preventing manipulation by simply returning non-responses or no such domain responses. Let's take a quick look at DNS in action. So the client stub resolver might issue a query, for example, uchicago.edu. That query might go to a local recursive resolver, or local resolver, which would in turn issue a query to a root server. The root server would return a referral to the EDU server, and in addition to the record itself, it would include a signature for that resource record, as well as the public key corresponding to the .edu server. Once the resolver knows the public key of the .edu server, it can then check any message that's signed by the .edu server, including subsequent referrals. And that process repeats all the way down the name server hierarchy until the stub resolver receives that IP address. Until the stub resolver receives the corresponding IP address. In summary, DNS is the protocol and system that maps internet names to IP addresses. DNS has historically not had any integrity or confidentiality protections, and so it can often be manipulated, and it is a common tool for internet censorship. Manipulation can occur at multiple levels of the DNS hierarchy. Manipulation can occur at the client's local recursive resolver or at higher levels of the name server hierarchy. DNSSEC is one defense against manipulation of DNS responses.